Namaskar friends, welcome to Electronics Technology channel. Topic of electronics technology news is urban heating and cooling to play substantial role in future energy demand under climate change. Existing global energy projections underestimate the impact of climate change on urban heating and cooling systems by roughly 50% by 2099 if greenhouse gas emissions remain high, researchers report. This disparity could profoundly affect critical, sustainable energy planning for the future. Existing studies predominantly concentrate on chemical feedback loops, which are large-scale processes involving complex interactions between energy use, greenhouse gas emissions, and the atmosphere. However, a research group led by the University of Illinois Urbana-Champaign focuses on the often overlooked physical interactions between urban infrastructure and the atmosphere that can contribute to local microclimates and, ultimately, global climate. A new study led by civil and environmental engineering professor Lei Zhao emphasizes that smaller-scale city-level waste heat from residential and commercial property heating and cooling efforts can lead to big impacts on local climates and energy use. The heat generated from heating and cooling systems is a substantial part of the total heat generated within urban areas, Zhao said. These systems generate a lot of heat that is released into the atmosphere within cities, making them hotter and further increasing the demand for indoor cooling systems, which feeds even more heat into local climates. This process is part of what researchers call a positive physical feedback loop between building cooling system use and the warming of local urban environments. The authors also note that rising temperatures under climate change could potentially decrease energy demand during the colder months, a negative feedback loop that should be considered in any temperature and energy demand projections. According to the study, less heating use would lead to less heat being released into the urban environment, inducing less urban warming than under the present climate. This process forms a negative physical feedback loop that may dampen the heating demand decrease, Zhao said. But it does not by any means cancel out the positive feedback loop effect. Instead, our model suggests that it could polarize the seasonal electricity demand, which poses its own set of problems for which careful planning is needed. To include these overlooked physical contributions into the larger overall picture of climate change, the team used a hybrid modeling framework that combines dynamic Earth system modeling and machine learning to examine the global urban heating and cooling energy demand under urban climate change variability and uncertainties, including the spatial and temporal challenges posed by the fact that cities vary in income, infrastructure, population density, technology, and temperature tolerance. I think the take-home message for this study is that energy projections that integrate the effects of positive and negative physical feedback loops are needed and will lay the groundwork for more comprehensive climate impact assessment, science-based policymaking, and coordination on climate-sensitive energy planning. Zhao's team is already learning how variables and uncertainties like humidity, building materials, and future climate mitigating efforts will further factor into their models to improve energy demand projections. Do you like this video? Please subscribe, share, like, and press bell icon for getting notifications of my electronics technology channel, and for searching my channel please write at the rate electronics technology 50.